Hey, thanks for watching. I'm Bob with Laguna Tools. Some people call me Router Bob, and that's a whole story how that happened. I was recently at a customer installation, and we were cutting solid wood furniture parts. And so we had to develop some special jigs because it was high production. And I came back to Laguna, I thought, man, what a great topic for a video. Let's talk about some production issues, because a lot of times we're using panel materials, plywoods, melamines, that kind of stuff, and flow-through works really well. So when you're doing kitchen cabinets, every nest can be different, and there's not really any setup. So there's really zero setup. Not every part can be held with vacuum, like that with flow-through. All right, and so what we've done in the past is we use double stick tape a lot. And double stick tape is a wonderful way to do things if you're doing what I call prototyping, and prototyping would be 10 parts or less. When you're in a production shop, that doesn't make sense, because maybe you're making 1,000 parts and it takes too much tape. So what we really had to do is go back to the way we used to do things, where we had what was called a dedicated fixture or vacuum fixture. And basically that used vacuum and some gasketing to hold a piece of wood onto the machine table. And that's how we used to do things back before this cabinet stuff all started. So I want to do a video about that. If I'm producing parts on a CNC router on a production standpoint, then I have to be able to make quick changeover. So I switch from one part to the next to the next. I can't spend a lot of time. It doesn't make sense. So in our fixturing system, we have to figure out a way to make that changeover very quickly. And we actually did that by developing what we call fixture boards and using them to locate on pins on the machine table. Now I want to stop a minute and let's talk about two terms that are used interchangeably that do not have the same meaning, and that's in woodworking the terms jigs and fixtures. A jig guides a tool, as in a dovetail drawer jig that guides a hand router. A fixture positions a part in a specific orientation for machining. And in our case, these are fixtures. Okay, this is a real nice part that I want to make. And it's a solid wood piece. It's a 1-inch thick material. And the main thing, it's actually got a profile all the way around it. So it's going to take some special fixturing, because my tool is actually going to reach underneath a little bit. So it's just a little bit different. Let's look at that first. Let's go through some concepts. I'm going to turn the computer on here and let's look at something on the screen here. The first concept I want to talk to you about is the concept of a fixture board. Okay? The key to being able to switch over from one setup to the next is using a fixture board that can be easily changed over. In my case, because our machine has a 4x8 table, I felt like about 1/3 of that was a good size. So my fixture boards are about 48 by 32, roughly that size. And I'm using 1/2-inch melamine material because it's fairly stiff, it's fairly flat, it vacuum seals to it very well, and it's not too heavy. It's easy to move around. So that's really the basis. And one of the things I try to do first is when I make one of those, I make several of them. I set them up on the router and make several of them. Now let's look at some of basically the details of that. If you look on the screen, that's what this is. Whoops. Here, let me flip this over. What you can see here now, all right, this is the board, and so this is about 49, and that's roughly 32. Okay, so this is the top side, and we'll talk about what this pocket is here later. Okay, now if you turn this upside down, what I've actually done is I've come in here and I've cut dados in there. So those are slots, and those are slots that they're like a vacuum plenum. They lay over the table, the grid table on the router, and vacuum transfers through those. That gives me the ability to access vacuum irrespective of the table itself. So it makes it a lot easier when you're trying to set stuff up. Also, if you look on this other side, we'll turn this over, you also see these two pinholes. All right? So basically those go on steel pins that I've mounted to the table, so I can take that on off. That's where the quick changeover comes from. Now, let's put this in perspective. Now what you see right here is a fixture board. Let's put a table behind it. Now all of a sudden there's a router table, and let's render this so you can tell more. But now there's what it looks like. So this is the actual grid table that's on the machine. And it's a good time to talk about this. The concepts I'm explaining to you now are not just, we're going to run a Smart Shop 2, but they're not just the Smart Shop 2. They're the D series, they're the new Smart Shop 1, the Smart Shop 2, the Smart Shop 3, the Pumas. All of the machines share this common vacuum table orientation. So what we're talking about applies to all of them. And so I put this on here so you can kind of get an idea of where that is on the table. We're going to go out the machine and actually validate everything we've talked about here. So that gives you an idea. And I'll turn some pins on and I'll show you where those are. So now, in fact, if I turn that fixture board or just shut it off, you'll actually be able to see those pins. There's one sticking up right there. And you see them sticking out. There's one of those pins. You can see its size. I'll tell you what those are. Those are steel dowel pins that they use in the machine shop. And they're readily available at hardware and industrial supplies. They're very consistent in size. I prefer 1/2 inch ones. You know, they come all the way from 1/4 inch on up. I like the 1/2 inch and the 1 inch ones. And what I've done on my machine table is I've actually machined a hole. There's actually 2 of these. There's one at this corner also. And what whoops, let me zoom into that so you can see it a little bit better. You see? So I've very carefully, I know where those holes are. They're all based on a drawing. So I've machined a hole here and back there. And that gives me those 2 pins that are sticking up. The pins are 1 inch long. They're going down into a hole that's about a 1/2 inch deep. Now when you do this, let me caution you something. Be very careful about the fit of the pins. If you start using them and you have to drive them in, they're really hard to get out. So I really want them where I can basically, they slip in and out. I don't want a lot of play, but I also don't want to have a pair of pliers or vice grips to get them out. So it's real important that when you drill those holes or machine those holes that you get them exact. Okay, so then what happens when I put that fixture board on you see the holes in the fixture board line up. And there's that pin sticking through. That's the secret to having a quick changeover. Now let's look at something else on here. I'm going to turn the fixture board off and the pin off, and so that we can look back at the table. In fact, I'll just leave that on. Now, in the grid itself, one of the things that I wanted to do, in fact, probably this is a better way to look at that. Things I wanted, things I wanted to do was I wanted to isolate the front of the table from the back of the table. These tables have 6 actual vacuum zones, 2, 4, 6. So what I wanted to do is to be able to have an area that was gasketed in here so that I could put all the vacuum in the front of the table where I'm doing this setup and separate that from the back of the table. And when we're out at the machine, we'll look at that. You can actually see the gasket on the machine, but what I basically did was went around these pins so that they're outside of the vacuum zone. So that's required for the setup on this fixture board. Okay, so that's where we started. Now, on the back of the machine, you know, I want to use my machine for cabinets too, or for nested base. So what I ended up doing is I started out and I took a 4x8 or 49x97 piece of MDF and I fly cut it. Before I did that, I cut it. I sliced it in about 1/3, so I cut about 32 inches off. So when I fly cut, there's actually 2 pieces there. That enabled me to take that front piece off and put one of my fixtures in there. So that was if you think ahead a little bit, there's times when I want to make cabinet parts with my machine, so that's why I did that. Then typically on the back side, I normally would just go ahead and leave spoil board on there, and so that's what that looks like. So when we go out to the shop, that's what the machine's that's what the setup's going to look like. And once again, if I could actually use these same principles of this fixture board and make one in a large area back here if I wanted. For instance, if I had a large tabletop or coffee tabletop. Okay, so now we understand what a fixture board is, how we position it, how we switch over quickly with those pins, and how it fits on the machine in the context we're talking about this. Now let's get into more detail. All right, we've got this part that's a certain shape. All right, we know the cutter's going to stick underneath it. So we have to have something, a part I call a riser, to actually keep the part elevated. So let's look at that. So I'm going to clear the screen off here a little bit so we're not quite so cluttered. We'll get rid of our spoil board. We'll get rid of our table. Now what we have is our fixture board. Let's bring that in closer. Now it's hard to see here. Let me turn something else. So let me x-ray that. Yeah, that doesn't come out too good. Let's try a... Ghosted doesn't come out too good either. We'll try shade. There we go. Now, here's basically what this is a pocket. This is the shape of the riser. Now, you got to think about when you're setting this up, you got to figure out where parts are on the table. And so, what I decided I wanted to do is I wanted to cut these risers at a 1/2 inch Baltic birch because it's a great material. It's always dense and it's pretty uniform in thickness. So what I wanted to do is I knew the riser had to be slightly smaller than the part because the cutter cuts underneath it. I knew it was going to be a 1/2 inch thick, and I needed to know how to locate it on the table. So I thought, well, why don't I since I've got the shape of the riser in the computer, why don't I just pocket an area out about a 1/16 deep, and then that riser sits right in there. And then at the same time, I went in there and put some glue on there, and actually you could nail it or staple it or put screws to hold that down. And technically, if you can actually turn the vacuum on, and the pressure of the vacuum will actually hold it down to the glue dries if you want to run your vacuum pump that long. Okay, now in that riser, or in that pocket, then goes a riser, and let's turn that on. And that's what the riser looks like. And let's go back so we get some color now. All right, that's what the riser looks like. So it's 1/2-inch Baltic birch. Now you see the common shape here. Now, but you see two grooves also. There's a groove here and there's a groove here. And those grooves are really important to this. This outside groove is used for gasketing, and there's what it looks like. Okay, the gasket is, you buy this in a roll. This particular piece is a 1/4 inch by 1/4 inch. It has pressure sensitive adhesive on it. So you just basically go around and you cut a 1/4 inch wide slot about 3/16 deep. You press that down in there, and if you've done it correctly, the gasket sticks up slightly, and that's the secret to holding this wood. That gasket flexes enough that once it seals the perimeter of that board, it'll pull it down flat. That's what makes it work. The second groove is basically a vacuum channel, and that's, once again, cut with a router bit. And one of the things, if I go to a top view, and let's go back to a rendered view of that, you'll see that there's a hole in here. Well, you can't really see that as well. There you go. There's a hole here, and there's a hole here. Okay, so those are in the vacuum channel. Now let's turn on the X-ray view, and you'll see, oh, what you're seeing right here. If these are the actual plenums underneath, or the channels underneath the fixture board to give me access. So I know then if I put a hole here, I can drill through there and I'll access vacuum. I don't drill all the way through. I drill about a 1/4 inch deep. When I get everything in place, then I take a hand drill and drill those holes through, and that connects vacuum to it. So that's how all that works. It looks complicated, but it's really very simple to set up. And we'll go back to the 3D view. So now, that's what that looks like. So that's basically the setup that we're going to use. Okay, before we go further into the setup, let's talk about the router bits that we're going to use. And I've got some unusual bits here. For one, this is a 3/4 inch straight, and it's called a chip breaker. And it doesn't give you a perfect edge, but it really removes a lot of wood, and it doesn't take that much power. So that's one of the tools I'm going to use. And what I'm going to use that for is basically to rough the shape out. Not a finished edge, to rough the shape out. Okay? Now, another tool that I use sometimes is similar to that. That's a finishing tool, and I typically use that if I want to produce a straight edge, and I want it to be really smooth so I don't have to sand. And then what we're going to do on this other part that we looked at over here is this. I want to put, this is a cabinet door edge detail, and I want to put that all the way around the part. Well, it sticks down underneath the part, so I have to accommodate that. So this setup that we're using here basically raises the part up on what I call a riser. And that gives me clearance, and that elevates that part. And you'll see that when we run the part. So those are the tools that I'm going to use. We're actually going to do our cuts on a Laguna Smart Shop 2 CNC. And I want to show you some more stuff here. I just happen to have in this 3D model, I actually have the machine frame, and I want you to see how it's built. So let's turn some stuff off here. There's the fixture board. Let's turn the frame on. And that is the frame of the Laguna. In fact, let's turn that table off so you can really see. You know, one of the things that you'll hear me say a lot when we do these videos is how important the rigidity in the frame and the frame structure is to accuracy of the machine and edge finish. And we get really, really, really good edge finishes, and the machine's very accurate. And this is why. This is actually a solid model of the frame on the Smart Shop 2. And actually the Smart Shop 1s and Smart Shops 3s are really the same structure. There's a little dimensional stuff. This is a 4x8. And what you see is one part there. That's not a bunch of parts bolted together. That's tubular steel. That entire structure is it's one single weldment. That's one part. That's why these machines cut so good. And you know, it's a clever system of the way that we design that. And then on that frame, then your table goes on there. You see. And then, of course, you see the gantry and the other stuff. But I wanted to show you that because, one, it gives you a perspective of where we're at and what we're doing here. And it explains a lot about that machine. Before we talk about toolpathing, we're going to actually toolpath these in VCarve Pro, and most people know I really like that product. But I want to talk to you a little bit about 3D modeling, and the software I've used here is Rhino, and it's Rhino version 5. This happens to be the Windows version. If you are a Mac person, the Rhino 5 for the Mac is still available as beta, and it's free, so if you want to play with it. The reason I point this out is I did this 3D stuff in Rhino because it's easier to explain things if you see it in 3D. There's another part of that. When you have interacting parts, it's a lot easier to get hosts to line up if you're dealing with that. This 3D modeling really adds another dimension to your woodworking. Now I prefer to create things as a model first before I machine them. It really helps you, think more clearly on it. And also, there's a lot of good training, real economical online type training now for these kind of products. So, you know, if I would certainly recommend it that you give it a try and see if you like it. Okay, now let's look at VCarve Pro. I basically have VCarve Pro opened up, and you can see on the screen here, that's the fixture board that you're looking at. And if I turn some layers on, you'd see some holes in the undercuts. But what I want to focus on is where I'm going to place the part and what machining operations that I'm going to do. So one of the things that I worry about with these solid pieces is that these corner chunks break off and fly. So I did these two areas first, and these are just basically pockets. So I'm going to take one of those rough bits, and here's a really good way to view that. That's what it's going to do. It's going to knock those out. And hopefully that keeps some of those from flying. Okay, then that same bit I'm going to come around, and I'm going to go around the perimeter. And if you notice, I left it fat here. Okay? Well, I left it fat because I want some material for that round over tool to remove. So then this tool, this actual tool path that you see here, is that profile cutter that goes around it. Once again, I did it in a rough pass, finish pass. If you'll do that, you'll get a lot better edge finishes. Typically, on some of these materials, climb cut works better than conventional. Sometimes you just have to try both and see which one works. If you cut it and it's rough, try the other, and that usually fixes it. All right, and so then the final pass is actually takes it to the actual size, and that gives me a really, really nice edge here. And when I'm dealing with solid wood, I want to make sure that I don't create mechanical things that have to be sanded out. That's where the frame rigidity comes from. That's, you know, if you don't have a rigid frame in the machine, you're going to have chatter, and you have to sand that out. And that's below surface chatter, so it's real difficult to get rid of. So it's really important that I do everything I can to try to get an edge that is as sand-free as possible. While we're looking at the VCarve Pro, let's say that we wanted to make this part without that contour edge. We want it straight. And so in that case, I probably use a fixture using this kind of gasket material. And let's look at that, what we would actually have. Now, I put a little extra view in here so you can see a little bit more. Let's turn the toolpaths on. One of the things that what I would actually do is put that mat on there and come over here and machine the groove. So really all I've got to do is apply this to the surface and cut the vacuum channel, and that's what you see in this drawing on the computer. That's what these lines are here. And then that gets access down into the plenum underneath, and that's how vacuum gets to that area. So it's a really, really easy way to do it. Now, toolpath wise, if I were going to make this same part except with a straight edge, not a profile edge, so the part can be flat on the surface, here's what I do. Same thing. I get rid of the corners because I'm worried about them flying. Okay, I rough the profile out. Once again, I'm using that chip breaker tool, so it's going to leave a fairly, it's an aggressive tool, but it's going to leave a fairly rough edge. Okay, then I come back and I use a finisher. So before I use that profile tool for the edge, in this case I use the 3-flip finish. Everything else is the same. The only difference in setup is the more complex setup requires that the part be on a riser for tool clearance, the other doesn't. So both of those are great ways to fix your solid wood parts. Now, let's go out to the shop and let's validate this. The machine I'm going to be using today is a Laguna Smart Shop 2 CNC. This particular machine has a HSD 11 horsepower spindle, and it has an automatic tool changer. Okay, before we do the setup on the machine, I want to point some things out at the vacuum table that we talked about earlier. This is more clear. This is a universal vacuum table, and remember, this applies not only to this machine, but the D-Series, the Smart Shop 1, 2, 3, and the Puma. So any of those machines basically have this type vacuum table, so what we're doing here applies to that also. Okay, first off, we have a grid system, and the grid system is basically used as a vacuum plenum to circulate vacuum underneath the sheet. All right, and it has actually 6 zones. They're broke into 2, 2, and 2. Now, what I've done on this particular setup, I've decided that fixture board we talked about a third of the table is real easy to handle. It gives me the capacity to do a lot of different setups, but it's still physically easy to handle. So what I've done is I've come over here and I've actually zoned out with gasketing this area and the back area. So I've got 2 completely different zones, and that allows me to leave one area set up a certain way and then make changes on the other. Now, you'll also notice that this gasketing has gone around this corner because these are the part locator pins that I'm going to be needing. I want my machine set up to be as flexible as possible, because some days I cut cabinets, some days I cut panel material, some days I want to make solid parts and need special fixturing. So I have it set up a little bit different than normal, and that is that my spoil board itself, the MDF panel, is actually split here, so I can take this front part off and still use the back part. And remember, that's why we gasket it that way. Okay, this is one of the sample fixture boards that we talked about. And that is, it gives me the ability to make quick changeover and have multiple setups and cut different kind of parts. So this is the back side of it, and you see the grooves that are actually cut in it, and that gives me vacuum access to the top real easily. The secret to this system working with the fixture board are these two holes. Those holes fit over the pins that are in the table. That way I can take a fixture on and off, and it's always in the same relative position. Now let's apply this to the table. All right, we've got the fixture board attached. Everything lines up with the pins, and this is a secret to being able to do quick setups, to make quick changeovers from one part to the next. The boards always fit on those pins in the same way, so I don't really have to waste a lot of time in setup. I've placed the fixture board for our special application here on the table. Now this one has a riser on it. Now here's why. This is a part we're making, and this part is machined all the way around. So that means the cutter comes underneath it. So I have to have a way where the part gets raised up so that the cutter clears. And that's why I use this, what I call a riser. Now let's look at more detail about the riser. Okay, this is the gasketing that we talked about. It's barely sticking up this surface so that it presses up against the wood to seal. Inside of that is a vacuum groove, and there's a vacuum port here and here, and those go in and tie into those channels on the other side that we looked at on the fixture board. The shell I cut on the outside is simply a boundary of the finished part, so that when I put the blank on there, I'm sure that I'm covering the area correctly. Okay, we're just about ready to cut our part. Now let's review what we've done so far. Basically, I turned the vacuum off on the back of the table, so all the vacuum is focusing on holding our part. I made sure that the blank is centered over the riser. Everything looks great. I turned the vacuum on. Everything looks go. Now it's going to be a little bit noisy when it's running, so let me tell you what's going to happen. First thing that's going to happen is a 3/4 inch chip breaker bit, which is a hogger bit, is going to come over and it's going to machine these corners off. That's what's going to happen first. Then it's going to come around and it's going to make just a rough pass, and that pass is leaving the material slightly oversized. The machine's going to change tools, and it's going to take that profile cut that's going to cut the edge, and it's going to go around it, first the rough pass and a finish pass. And that's what you should be able to see. That came out absolutely great. What a beautiful edge. All right. Okay, the setup on this part required that it be elevated, and that's why we had the riser on our fixture board, so that to hold it up to allow the cutter to wrap underneath there, because it's a full edge shape. That's not always the case. Sometimes what we're trying to do with fixturing is do this on a production basis where we have parts that have to be cut out that require special fixturing, but not necessarily for the cutter to reach underneath. That's what we're going to do in this next demonstration. In our previous setup, we used this square gasket. It's actually got pressure sensitive adhesive on here. It fit down into a groove and it extended about a 1/16 of an inch. That works real well, and it works great for larger parts. However, it takes a little more time. There's a couple extra steps. In this setup, we're going to use this sheet gasket, and it comes in a roll. It's real easy to cut. It has peels off, and you basically lay it out on the fixture itself, and then cut the slots in there, time into the vacuum, and you're ready to go. It's a really fast way to set up. Okay, this fixture has actually holes here and here to let vacuum come through from underneath and circulate around these grooves, and that pulls the part down, and the rubber gasket here seals it. So all I have to do is line the part up. Once again, I know where the outline of the part's going to be. Turn the vacuum on. Well, we hope you enjoyed this video. I wanted to do something that's a little out of the ordinary, that's not making cabinet parts or something simple. So, and I wanted to go back to the old days where, when this is what we use CNC routers for, and every part required a fixture. And people have forgotten how to do that. So hopefully that helps you. If you have any more questions, please go to lagunatools.com, or you can call us at 1-800-234-1976. Thanks for watching.